Greetings, ladies and gentlemen. Thank you for joining me in today's presentation. We're looking at dimension analysis. This is physics. For you to understand the concept of dimension analysis, you have to understand the difference between fundamental units and the derived quantity or unit. Let's look at three key things that you need to know as far as dimension analysis is concerned before we dive into examples. Uh, for you to understand dimension analysis, there are three key things. Number one, time. The dimension for time is t. Length. The dimension for length is L. Then mass. The dimension for mass is m. Very important. Let's look at, maybe we are asked to find the dimension of force, velocity, or acceleration as the case may be. Let's say example 1, we are asked to find the dimension of force. How do we find the dimension of force? Very important. Recall that force is mass times acceleration. Okay, and we know that the dimension for mass is capital M here, so we don't have problem with this M. What about acceleration? Acceleration is nothing but change in velocity with respect to time. Let me use capital T now because time here is capital T. Okay, very important. If acceleration is change in V with respect to time, then what is velocity? Velocity is change in displacement with respect to time, and displacement is measured in what? Length. That's meter, which is length now. Okay? So it means velocity V will be length, that's displacement now, divided by time t. So the dimension for velocity now, we are using the dimension of force now to get the dimension for both acceleration and velocity. So the dimension for velocity now will be Lt power minus 1. We can write it like this in square bracket. So this will be the dimension for velocity. Okay, but what we're looking is that of acceleration to find the dimension for force. Okay, acceleration now, it will be change in velocity, but the dimension for velocity is Lt power minus 1 divided by t now. Okay, this t has a power of 1, and if we take this t up, this power will, positive power here will gain negative power. So the dimension for acceleration now will be Lt power minus 2. Because if we take this minus 1, it will be minus 1. Minus 1 minus 1 will be minus 2. Okay, so this will be the dimension for acceleration. So we know now the dimension for velocity as well as that of acceleration. So finally, the dimension for force F now will be equals to m, which is mass, to be capital M now, multiplied by acceleration. The dimension for acceleration is Lt power minus 2. So finally, the dimension for force now will be equals to m Lt square. We put it in square bracket like this. Very important. So this will be the dimension for force. You can see clearly that we have velocity and that of acceleration. So we have used this concept now to explain three, or how to find the dimension of these three physical quantity. That's velocity, acceleration, as well as force. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to TJ's Maths and Further Maths Adventures for more interesting and amazing videos. Thank you for watching.